Okay, so this video is going to be about finding the volume of prisms. So really quickly, I just want to talk to you about what a prism is, and then we'll kind of talk about how to find the volume of it, and also what volume is. So the first thing I want to talk about is what is a prism. Okay, so there are kind of two big categories of three-dimensional solid figures. There's prisms and there's pyramids. We'll be talking about both, but pyramids are going to be in the video to come. Prisms are three-dimensional figures or three-dimensional solid figures that have two parallel bases. Okay. The idea that the bases have to be parallel is also how it's going to help us realize how to identify which are the bases of the solid figure. Let's see some solid figures. Okay, so a cylinder, or you can also hear it called a cylindrical prism. You'll see that the circles are the bases, okay? Yes, there are two circles, but it's also important to realize that the circles are, that they are parallel to each other, okay? What you should never make a mistake is saying that the base is where the object stands on. So if you were to take a look at this pentagonal prism, okay, it looks almost as if it's standing on this this quadrilateral, okay? And so you would want to say maybe that the base is that square, but it's not. It's actually the pentagon, okay? There are 5 quadrilaterals that go around your 2 pentagons, and so your 2 parallel pentagons as well. All your quadrilaterals, none of them are parallel to each other. So the only ones that are parallel and that there are 2 of are the pentagons, okay? And then with your rectangular prism, you actually have several options as to what you want to call the base, and it does not matter which one you call the base. So these 2 could be the bases here, okay, the top and the bottom. Okay, they're 2 rectangles, they are both parallel, still making it a rectangular prism. Again, it doesn't have to necessarily be the side that it stands on to be considered the base. So I could technically call these 2 rectangles the bases as well. Again, there's 2 of them and they are both parallel, still making that figure a rectangular prism. The other idea is that your prisms are actually named off of their bases, okay? So a cylinder is actually a little bit unique, but the bases of this one was a pentagon, so it's called a pentagonal prism, okay? This one is a rectangular prism because the bases are rectangles. If there was a triangular prism, that's right, the bases would be 2 parallel triangles, okay? So now let's talk a little bit about volume, okay? So I'm actually going to talk again about these figures. I'm just going to take away the, not going to do that. I'm just going to take away the pentagon. Okay, so let's take a look quickly at these figures and kind of identify what volume is. So volume is the space inside a three-dimensional solid, or you could think of it as how much can you fill a three-dimensional figure with, okay? So a lot of the times it's easy to think of like a cup and how much water it could fill. That would be the volume of the cup, okay? Or how much tissues can go into a tissue box. That would be filling the tissue box. That would, of course, be the volume, okay? We use a very general form for the volume of prisms, okay? We also use a general form for the volume of pyramids, but we'll get to that in a later video. So the area of your, the volume of your solid figures are going to be found by taking the area of the base, and then you're going to take that and multiply it by the height of the prism. Okay? Now for just a second, I want to talk to you about why this formula makes total sense to us. So let's talk about this cylinder. So the cylinder has a circular base, okay? We're talking about filling the base. Well, if you think about it, you're covering this area, this circular area right here, okay, as many times as what the height is, okay? So if you have a height of 9 inches, okay, you have this circle that's being filled 9 inches high, okay? So you're gonna always find the area of the base and you're gonna multiply it by whatever the height of the prism's gonna be. Now it's important to realize that, of course, aside from measurements are always gonna change numerically, but the area of the base is pretty much the only thing that's gonna change in this formula. Depending on what the base is, you would have to find or use a different formula in order to find that that area, okay? So for this one, the area of the base would be pi r squared, okay? Where in your rectangular prism, the area of the base is just length times width or base times height. Okay, and so I think we're ready to kind of jump into a few examples, okay? Let's first take a look at a rectangular prism, pretty easy. And you guys probably have seen this before. You definitely have seen this before. And you've probably seen it as length times width times height, which is totally true. But again, that length times width part, that's that area of the base. And because I want to stick with always following that same general rule, and I'm going to go ahead and kind of follow the same process for all of them. So instead of doing length times width times height and having a different formula for all of our prisms, I'm going to use the same formula for all of our prisms. So what we'll do is we'll use that big B to represent the area of the base, and we'll use the little h to represent the height of the prism. Now again, what I said earlier is that it doesn't technically matter what you want to call the base. You have 3 different rectangles on your rectangular prism that are all parallel to each other, so it doesn't really matter which one you call it. I'm going to go ahead and call the bottom one just because that's the typical go-to. So let's call the bottom one your base, okay? So the base here is going to be represented by the area of a rectangle. Okay, the area of the rectangle is going to be found by doing length times width. Just going to take this away so it's out of the way a little bit. Okay, and oops. Okay, and my length can be the 5 and my width can be the 2. Of course, we know at this point it doesn't totally matter how you multiply. The area of your base here is 10 square units, okay? So now I know that my area of my base is 10 and the height of my prism here is going to be 3. So that's your height of the prism. And so this rectangular prism would have a volume of 30, and then your units would be cubed for volume. So at this point, these units were squared. Then you have unit squared times another unit, which is going to make it units cubed. Another idea that you have seen in the past. Okay, and again, it wouldn't have mattered. So if you did call that 3x2 side your base, then your volume of your base would have been 6, and then you would have been multiplying it by the height of the prism, which then would have been 5, and so then that's still 30. Okay, let's take a look now at 2 different triangular prisms. I'll finish both. Okay, so then let's take a look at this right triangular prism. So it's just a right triangular prism because your bases here are 2 right triangles, right? Now, yes, you could call this just a triangular prism and that would be fine, okay? So you have you have a triangular prism or a right triangular prism, but it's still a prism. So you're still going to use that area of the base times the height. This time the base is going to be the area, or the big B is going to be represented by the area of a triangular base. Okay. Triangles have an area formula of half base times height. Remember, it's half of your quadrilaterals. Okay. Your base and your height in a triangle have to be perpendicular to each other. So your height can be the 3 and your base can be the 4, or vice versa. Okay. Either way you look at it, your area of your triangular bases is 6. Okay. So that means that I now just have to identify the height of my prism. So the 15 is going to be the height of my prism here. Okay, and so now you just have 6 times 15. So you would have 90 cubic inches. Okay, and the other triangular prism is going to be much the same. You have a base there of 10 and a height there of 8.7, and the height of the actual prism is 31. So you would be finding the area of the triangular base, so half of 10 times 8.7, and then whatever that result is, multiplying it by the 31 for the height. I actually want to now take a look at a hexagonal prism. Okay. So this is a hexagonal prism because the bases of this prism are hexagons. Okay. So we're going to start with that same general formula. Okay, because it's a prism, we're going to find the volume by doing the area of the base and multiplying it by the height of the prism. The 7 is going to be the height of the prism. We do have a little bit of work in order to find the area of the base, okay? And this has to do with your other that other videos that you watched, or if you're in the one class, you may have seen me do it, okay? The idea of your regular hexagon that you have here. So I know for sure it's regular because I have all congruent sides marked, so that's going to make it a regular hexagon, okay? Which means that the big B, that's the area of hexagonal base, okay? And because it's a regular hexagonal base, I'm going to use that half times the apothem times the perimeter, okay? So the perimeter would be easy to find, right? Okay, so I have, each side is a measure of 4 millimeters, and I have 6 sides, so that's going to give me a perimeter of 24 millimeters. Okay, I do have a little bit of work to do for finding my apothem. Okay, so the first thing that I'm going to want to do is just kind of sketch in my apothem really quickly. Okay, just to remind you that your apothem goes from the center to the midpoint of a side. Okay, that means this is split to 2 and 2. Okay, it is also perpendicular to your sides, and you're looking for this length. Okay, if I draw my radius here, I'm going to end up with a right triangle that has a base of 2 where I need my height. Okay, I don't know what my radius is, so I'm going to have to figure out an angle so that I can find so that I'd be able to figure out using trig what the height would be. Okay, so a hexagonal prism, a hexagon totals 720 degrees, right? Because we addressed the other day that it's the number of sides minus 2 times 180, right? Or there's 4 triangles, so 4 times 180 is 720. Now your 720 degrees is split evenly among your 6 angles, making each angle 120 degrees. But your radius is also an angle bisector, which means that this right here is a 60-degree angle. Okay. And now you do have a 30, 60, 90 if you want to use that, or you can use trig. So remember what I said, that the special right triangles, your 45, 45, 90s, and your 30, 60, 90s, they won't be able to be used for any regular polygon, but trig can be used for any regular polygon. So I would recommend kind of just remembering how to use trig here. So I need to find my opposite side, and I know my adjacent side, so I'm going to use the tangent function. So the tangent of 60 degrees is going to be equal to my opposite side over my adjacent side. I'm going to rely on my calculator to help me out here. The advantage to using your special rights is that you would have an exact answer. Here we're going to have to use a rounded answer, but eventually you would use a rounded answer anyways. So we'll use 3.46 as being my apothem height. Okay? So now I'm going to go back up to my prism. I now know that my hexagon has an apothem height of 3.46. Okay? That means I can now find the area of my hexagonal base. So let me just quickly type that in. And it's going to give me an area of about 41.52 millimeters squared. And that was the worst part of it. Because now I'm going to go back into my my formula or rule that I'm following to find the area of prisms and just plug in. The worst part of it has already been done. So now I just have to basically multiply by 7, and the volume of this hexagonal prism, 290.64 millimeters cubed. Okay, let's do one more, a little bit different. It's our cylinder. Okay, so your cylinders have circular bases, okay, which means that you're going to have pi involved in this one, okay? So you have the volume being the area of the base. The base is going to be the area of a circle, okay? The area of the circle is going to be found by doing pi r squared. I have a radius here of 64. So that's going to give me a radius of 8. So that's going to give me an area of 64 pi. And do not ignore the pi, although we will try our hardest to leave our answers in terms of pi. So the volume here, my area of my base is 64 pi, and the height of the prism is at 12, okay? Which is going to give me a volume of 768 pi centimeters cubed. Okay, and that's it for the first video. Next video, we'll talk about volume of pyramids.